Okay, for the first one, you combine magnesium and oxygen, and it gave off magnesium oxide. Oxygen is diatomic, and so when you balance the equation, you need 2 magnesium oxides, 1 magnesium, and this is a combination reaction, also known as synthesis. For the second one, you took magnesium and you added it to hydrochloric acid. It's a single replacement, so if magnesium comes in and replaces the hydrogen, so you have magnesium chloride and hydrogen. Hydrogen is diatomic, chlorine is a -1, magnesium is +2. And when you balance it, you will find that you need 2 hydrochlorics, and then it's balanced. And this is, as we mentioned, a single replacement reaction. Okay, next one, then you took the hydrogen and you burned it in the presence of oxygen with the splint, and it forms water. Hydrogen and oxygen are both diatomic, and so you need twice as much hydrogen as you do oxygen, yielding 2 molecules of water. This is also a combination or synthesis reaction. And the next one, you took copper and you burned it in the presence of oxygen, and you made copper oxide. Now, depending on the charge number you gave copper, it could be CuO or CuO2, but most likely it was CuO. I wouldn't expect you to know that. On test, I would give you that kind of information. But this is what it would look like here. Once again, this is a combination or synthesis reaction. Okay, next one. NH4, 2, CO3, so ammonium carbonate. And it was a decomposition. It decomposed to ammonia and water, which you tested for with cobalt chloride paper, and carbon dioxide, which you tested for in the splint, and that's the one that went out. So this is a decomposition reaction. And to balance it out, 2 right there. It's all set. Okay, the next one you did was a decomposition as well. You took hydrogen peroxide and you used manganese dioxide. Notice I'm putting it right here because it did not get used up at all. It stayed the same throughout the whole reaction. It's called a catalyst. It just made the reaction go faster. It was not involved in the actual reaction. And that yielded water and oxygen. To balance it out, the 2 hydrogen peroxides, 2 waters, and 1 oxygen. Notice oxygen is diatomic. And once again, that is a decomposition reaction. Okay, next reaction we did a potassium iodide plus lead nitrate, and that yielded lead iodide and potassium nitrate. Okay, notice that the, oops, that should be a 2 there, because it's lead 2 nitrate and lead 2 iodide. So therefore we need 2 there and a 2 here. And this is a double replacement reaction. Okay. Last one we did, we took copper carbonate, copper 2 carbonate, and we formed copper oxide and carbon dioxide. And that's already balanced. That's a decomposition reaction. And then we took that same carbon dioxide and we bubbled it through, oops, excuse me. Well, I'm getting ahead of myself. Okay, that's good enough for the reactions. For question number 2. With the lime water, we took the carbon dioxide then from the copper carbonate decomposition, and we reacted with lime water, calcium hydroxide, and we ended up with calcium carbonate, which was what was making the water cloudy and water like that. Okay, question number 3. Positive test was the pop test. That's where we took the hydrogen and we burnt it with the splint, in the presence of oxygen to form water. So a balance equation is going to look like this and this. And that was about it.